Happy Friday, JD Parker students. Today is May 15th and it is our 34th day of virtual learning. Today we are working on reviewing fractions and decimals. This is the units we just finished off with before we started this week of review of fourth grade standards. We did fractions and decimals. We're mostly going to review fractions today, and then you're going to do Khan Academy activities, and they are going to take those grades and they're going to send them to me. So you will not have a worksheet page to do today. So fractions, let's review fractions. There's types of fractions. So there's a unit fraction. A unit fraction is basically a fraction in its smallest unit form, which means it has a 1 as a numerator. It's as small as it can go down without changing the total amount of units. So 1 unit, so this is 1 out of 2, 1 out of 4. Now you also have a mixed number, which is a type of fraction. It has a fraction, but it has a whole number. It's like a whole number and a fraction put together. A mixed number is bigger than 1. Also bigger than 1 would be what we used to call improper fraction. Now we just call it a fraction greater than 1. But it used to be called improper because you can take out 7 out of the 16 and get your wholes. But now we just call it a fraction greater than 1. But people still refer to it as improper fraction. Proper fraction is just a regular fraction. People usually don't use this term proper. They only tell you when it's improper, which means the top numerator is bigger than the whole bottom. But a proper fraction is just referring to a fraction. Equivalent fractions. This is super important that you understand to do. This is what I'm going to go over today. Equivalent fractions are fractions that are the same value, but they're written differently. So a half means you have half of something, but you can cut that half into more pieces and you get 2/4 or 3/6 or 4/8 or 5/10 or even 50 over 100. Half is when the top numerator is half of the total amount of pieces, the denominator. So anytime you see a number that's half of the bottom, you just call it half. Simplifying fractions. Simplifying fractions, I think, was the hardest concept for most of you to grasp, because instead of multiplying to get an equivalent fraction, you're now dividing to get it as small as it can go. You can always multiply the numerator and the denominator by the same exact number and get an equivalent fraction that is bigger. But instead of multiplying, if you divide, you get a fraction that is smaller, that is equivalent but smaller. So 3/6, if you divide the top by 3, if you divide the bottom by 3, you would end up getting 1/2, so smaller. You divide to get it to go down to its smallest form. Now, how you tell a fraction is equivalent or equal is you can do my favorite. It's cross multiplying the butterfly method, where you start at the bottom and you cross over and multiply the other numerator and write the answer at the top. So 6 times 1 is 6. 2 times 3 is 6. 6 equals 6, so these are equal. If you've got different numbers, you would just open the mouth to the bigger side. Equivalent just means they are exactly the same, and here you have a half. 1 is half of 2, and 3 is half of 6. So you can even tell looking at these that these are equivalent halves. Not equivalent, you put this little mark through, and we've talked about this a few times. This means not equal. Not equivalent or not equal just means it's not. Or you can use the open greater than less than symbol to show the greater or less than side. And then fractions. In a nutshell, your numerator tells you how many parts. The denominator tells you how many parts are all together in your whole. So you could have 5 parts, but there could be 6 parts in the whole. So the bottom tells you your whole. Now, if you have a fraction greater than 1, then your numerator is going to be bigger because you have more parts than the whole. So here is a fraction that's greater than 1, and you can change this fraction into a mixed number, just thinking about how many 3's you can pull out of the 7. You can pull 5 3's out of the 7 with 2 left over. Basically, you find this out by division. And then getting into decimals just a little bit, and also fractions still. Money. Money is a great way to think about decimals or even fractions. You want to really apply the penny and the dime to understanding this. Penny is there's 100 pennies in just one whole dollar, which means 1/100th of a dollar is a penny. So here you have a nickel. Nickel means you're going to have a 5 in the 100th spot, as you can see by the decimal notation, the fraction notation, and the decimal money notation here. Dime, there's 10 dimes in $1, so it's 1/10. So you put a 1 in the tenths. You can put a 1 over 10 or 10 over 100, or even again a 1 in the tenths or tenths in the hundreds. So there are 10 cents here, and when you have 10 of these, you get a dollar. Quarter, there are 4 quarters in a dollar, 25, 50, 75, a dollar. So 25 over 100 is a quarter. If you were to draw this out in fraction form, you could draw a nice little circle, cut it into fourths, and color in 1/4 because there's 4 quarters in $1. And of course, $1 bill is one whole dollar. It is 100 cents over 100 cents, and it is 1. And decimal notation is just 1 in the whole. And a quick little, I like to think of it almost as a cheat in order to go to tenths to hundredths. So let's say you have 6/10. Ignore this bluish purple color right now. Say you have 6/10 and you need it to be in hundredths form. Well, just add a 0 to the top and add a 0 to the bottom. You're basically multiplying times 10, and whatever you do to the numerator, you must do to the denominator. Whatever you do to the bottom, you must do to the top. So times 10 would easily convert it. You can actually just add a 0, because when you multiply any number by 10, you just add a 0. So 6 times 10 is now 60. 10 times 10 is now 100. And the same thing when you're doing decimal form. You can always just add a 0, and 6/10 now turns into 60 hundredths. So I am going to very quickly go over the only 6 problems you had to do yesterday. Well, you had to write the answers and just plug them in. So number 1 obviously was 50. 52 was number 2, and I gave you those. So perimeter is the distance around the outside of an object, and here you have a quadrilateral rectangular object. So perimeter would be this plus this plus this plus this. 4 sides. 25 plus 25, I know is 50. 40 plus 40, I know is 80. When you add 8 plus 5, you get 13 and 0. So the perimeter to number 3 is 130. The perimeter to 4 would be 16 plus 18, and also another 16 and 18. Now, let's see, 16 plus 18, you would get 14, 34. So perimeter is going to equal 34 plus another 34, which is 68 meters. So all you had to do here is write 68 and here 130. And I told you didn't have to worry about the ending yet, because I know it's very difficult to write it typing it on a computer. And I gave you the answers to 1 and 2 for area, length times width. Length times width. Here you have length times width. Area. So what is 5 times 5? It is 25. And you did not have to write this part, just the 25. And now you have 14 and a 7. So 14 times 7, which is 98. And on the back, you only had 2 problems to answer on the back. You had the area for this looks almost like a C shape here. I would choose to do the big area first and then take away this empty spot. So I see it's 8 here and it's 20 here. 20 times 8 is 160. Now all I have to do is get rid of this little section that they cut out. They're telling me right here with this arrow that this back wall is 12, and then the sides are 4. 12 times 4 is 48, and then I would just have to subtract it. And you would get 112. And then last but not least, what is the missing side here? They're telling you the area is 7 times something equals 56. So if you needed to draw out an array, 1, 2, 3, 4, 5, 6, 7, it would have looked something like that. Now I have 7. How many across do I need to get to 56? Honestly, I mean, you could have just started cutting it and counting. That would take you a while, but hopefully you know 1, 2, 3, 4, 5, 6, 7, that 7 times 8 is 56. And since that's an MI for miles, that would be an MI, which you did not have to write, but you will next year. So I just want you to see it. So I'm very quickly going to go through 2 pages of all the skills. So all the lessons are broken down. So the very first lesson we learned in chapter 6, quite a long time ago, right after Christmas break, is to find out whether these are equal fractions or not equal, equivalent or not equivalent. Remember, equivalent is a very fancy word for equal. So 5 is half of 10, 1 is half of 2. I know these are equal, and if I cross multiplied, I would have saw they're equal. Let's skip to something harder. Let's do 8 times 3, 24, 6 times 4. Oh, we found another equal one. Let's try this one. 12 times 4 is 48, 6 times 7. So you're going to open it to that side. That is definitely bigger. Write 2 equivalent fractions for each. Well, I know this is half because 5 is half of 10. And I also know that 10 is half of 20. I know 20 is half of 40. You can make up half all day long. Just whatever you write for the top, make sure the bottom is doubled. Let's see. How about this one? 4/5. Multiply the top and bottom by 2. You'll get 8/10. Multiply the top and bottom by 3. You'll get 12/15. Multiply by 4. 16/20. If you remember us doing this, you guys loved this. I gave you the paper and you found the pattern in it. But in order to find equivalent fractions, you just have to make sure you do the same thing to the numerator that you did to the denominator, whether it's multiply or divide. You can divide too. So I can divide the top and bottom by 2 on this, and I would get 2, 6. That's cutting it by 2 in half. If I multiply by 4, I would get 1/3. And these are all equal to each other. And I could go backwards. 1 doubled is 2. 2 doubled is 4. 3 doubled is 6. 6 doubles is 12. And I could even go up higher if I want. Write the fraction in simplest form. For some reason, this is the one that usually gets kids because you have to divide instead of multiply. Simplest form means they want the smallest denominator as possible. So in order to do this, you have to be aware of what the numerator is and the denominator. And you have to say, I wonder what factor these have in common. Well, they both have a 2 because 2 times 3 is 6 and 2 times 6 is 12. They both have a 3. 3 times 2 is 6 and 3 times 4 is 12. But they both also have a 6. So I'm going to divide the top and bottom by 6. Well, look how small I can get that. 6 divided by 6 is 1. 12 divided by 6 is 2. And by the way, this is also a half. 6 is half of 2, and that's the smallest as you can go. Over here, you have a 6/10. I can divide the top and bottom by 2. By the way, that's what I suggest. If this is confusing you, if they're even, just divide it by 2. If they're both still even, divide it by 2 again. If they're both still even, Keep dividing by 2 until you get there. Dividing by 2 is one of the easiest ways. So 6 divided by 2 is 3, and then that is 5. That's as small as you can go because that's prime and that's prime. All right, and coming down here, common denominators. This is going to, you're going to be doing this a lot in 5th grade. Common denominators means that denominators have to be the same. And why is that important? Because when a denominator is the same, now you can add and subtract it. You can leave it alone. Once you make it identical, you can leave it alone. So like these two right here, these denominators, one is a 3, one is a 6. I can make them both be a 6. Because they both, a 6 times 1 is 6 and 3 times 2 is 6. It doesn't matter what you pick, but for adding and subtracting purposes, you don't want to try to pick a high number. You want to try to stay as low as possible. 3 times 2 is 6. Do the same thing to the top. 2 times 2 is 4. And this was just, we left it alone. Here we have a 5, we have a 2. Well, they don't have any factors in common, but they do have a multiple in common. They can multiply to each other. 5 times 2, 10. 2 times 5, 10. They both have a multiple of 10. So 5 times 2 is 10. So that means 3 times 2 would be the answer for up there. 2 times 5, that means 1 times 5. So here they are here. The easiest way to find a common denominator is to multiply them together and get a common denominator. But don't forget, you can't leave the top alone. If I multiplied the 8 times 4, I got to do the 7 times 4. They both have to be multiplied by 4, and over here, they both have to be multiplied by 8. Over here, let's see. This one here, 3 and 4. Well, 3 times 4 is 12, so I can use 12. And then 3 times 4 is 12, so I'm going to multiply by 3 up here. I multiplied this by 4, so I multiply this by 4. And this is important because you're going to get into adding and subtracting next. Before we do that, writing the fractions in order from least to greatest. This is the littlest to the biggest. So looking right here, the easiest way is to find a benchmark. I see a half. That I know is going to be my middle because a fourth looks like this. That's less than a half. And then 5/8 I know is bigger than half because 4 is half of 8, so 5 is bigger. So you can put it in order if you can look at it and just find a fraction that can help you determine whether it's bigger or smaller than the rest. A half is a great benchmark fraction because you can look at that and you can say, well, is a fourth bigger or smaller than half? Is 5/8 bigger than smaller than half? Same thing over here. Like I know 9/10, that's almost a whole. 1/6, that's almost like hardly anything. One little piece out of 6, but here you have a 2/3. So you can almost see it. It would work out like this. Moving on to the next section, adding fractions and subtracting fractions. Adding fractions and subtracting fractions are super easy if the denominators are the same. Here you have 1/6 colored in. Here you have a half, 1, 2, 3, 6. And you just add them together. So here's your half. Here's your 1/6. You get 4/6. You just add the numerator straight across. And once they have the same denominator, you leave the bottom alone. Subtracting, once they have the same denominator, you leave the bottom alone and you just subtract the top. So if you have 7/12 and you take away 6 of those, you're left with 1/12. It makes sense. This is unit fractions. Unit fractions means the numerator is 1. So how many 1/3 would it take to get to 2/3? It would just take 2. 1/3 plus 1/3 equals 2/3. Or if we were multiplying, we could say 2 1/3 would equal 2/3. And let's see, 5/12. 5/12 would be, well, you have the denominator is 12. How many of those 1/12 would it take to get to 5/12? It would take 5 of them. 1, 2, 3, 4, 5. So that's how you do unit fractions. This is how you add fractions. You have the same denominator. Same thing with subtracting fractions. And when you are trying to find which fraction is greater, less than, or equal to each other, you can cross multiply, unless you can just look at it and tell. Like, I know 1/4 is small. 6/8 is bigger than half, because that would be 4/8. So 6/8 would be like that much. So I know it's that much bigger than this one. You can look at it and just tell which one's greater, or you can do the butterfly cross method. All right, so there is no secret word of the day, but what you're going to do today is just do the Khan activities now and enjoy your weekend, my friends. Next week, we begin 5th grade level. Goodbye.